Now that we've seen some ways that we can compare our data in the earlier part of Chapter 12, in 12.5 we're going to be focusing on getting those pieces of data in the first place. So 12.5 samples and surveys starts with a question we're going to look at the beginning of this. Manager of a Thai restaurant wants to know how often people in her city eat Thai food. She surveys 200 of her customers and then says that the results in the histogram shows that most people in the city eat Thai food at least 10 times per year. So we have to think if there are any problems with that survey. So it looks like even if she took some accurate results and put those into a histogram, the issue in getting that survey in the first place is if you're sampling only customers at a Thai food restaurant, you expect them to eat Thai food a lot more than just people in general that haven't been to that restaurant. So yes, sampling her customers is not an accurate sample of all the people in their city. That would be the mistake with her sample. It'd have to be a little bit more accurate if we're trying to expand that to everyone in the city, not just Thai food customers. So when collecting our data to solve a problem, you need to make sure the methods are fair and you accurately represent the results, so not like that first example. And we can collect data using either measurements or categories, and that's going to decide what kind of data we're going to have. So two sorts of data that we could use, quantitative, that has units that can be measured and numerically compared, so just think anything that you could use a number for, add or subtract things together, find an average, so something like age, weight, time, anything that you could measure. And qualitative is going to describe a category of something that cannot be measured or numerically compared. So things like hair color, eye color, attitude, zip code. So even though you have a number for something like zip code, again, I can't take an average of any zip codes and have it mean anything. I can't count them together. It's just still going to be a category. So in that next data set, if we're deciding if it's qualitative or quantitative, school lunch costs would be an example of quantitative data because we can have higher lunch costs, we can have lower lunch costs, we can find an average of different lunch costs for different schools. Something like eye color, though, since it can only belong to different categories, like brown, green, blue, that would be qualitative data, not quantitative. So the kind of data you're working with determines the type of graph we use to display the data. Set of data that uses only one variable is univariate, so think unicycle, one variable, one wheel. Set of data that uses two variables, just like a bicycle, is going to be bivariate. So univariate means one, bivariate is just going to mean you have two variables. And if we're going to use that to decide in this next group if it's univariate or bivariate, our first example should be bivariate, heights and weights. Those are your two variables of different mammals. So you can measure height, measure weight, use those as your two variables for bivariate data. Internet service costs from different providers not going to be bivariate because the different providers just what you're measuring. Internet service cost is your only variable, so that would be univariate. So again, univariate just means you have one variable. Bivariate means you have two. Statisticians collect information about specific groups or objects of objects or people. The entire group that you want information about is the population, so think your larger group. When a population is too large to survey, statisticians survey a part of it to find characteristics of the whole. The part that is surveyed is called a sample. So think if our class was a sample of the entire school, a sample is just part of your population. So three sampling methods we're going to be using are shown below. When designing a survey, you want to choose a sample that best reflects your population. So those three, starting with a random sample, is just any kind of survey of a population done at random. So an example of that would be survey people whose names you draw out of a hat. That's a way to randomize it. Another type of sampling is systematic. So that's selecting a number n at random, then survey every nth person. So for example, if I just choose the number 5 randomly, I'm just going to pick every 5th person that I see in a group. So a little bit easier because you can not have to interview everybody, just interviewing every 5th or 6th or 7th person. Last type is called stratified. So that's when you are separating your population into smaller groups, each with some kind of characteristic they all belong to. Then we're going to survey at random within that group. So for example, if you separate your high school into 4 groups by grade level, you can then take a random sample of each grade, and that would be a stratified sample. So stratified, just think you're going to break that apart into groups. So we want to find out how much homework students do at ANHS do in a week. We interview all students leaving a pep rally who are sitting in the senior section. Will that give a good sample? And that example I don't think would give a good sample because if you're only interviewing the senior section and only sampling that grade level, they might have a different amount of work than other classes do. So seniors probably a little bit have less homework than most classes on average. And if you wanted to change that into a better sample, you might think you could do the same thing, but randomly sample from each grade level and make yourself a stratified sample. So a survey question can also have bias when it contains assumptions that may or may not be true. Bias can influence opinion, make one answer seem better than the other. Survey questions must be carefully worded to avoid bias. So sometimes bias will be kind of obvious, like I think in this next question is a little obvious. Sometimes a little bit harder to pick out. So for example, our reporter for the Wolverine Wire wants to find out what kinds of subjects students like. Reporter asked, do you prefer fascinating math classes or boring English classes? Is that question biased, and if so, how can it be reworded? So again, obviously you want to avoid words that kind of lead towards a certain answer. So avoid adjectives like fascinating, boring. So if I just reworded that question and still wanted to get a similar response, we could just prefer or say, do you prefer math or English classes? So again, doesn't have any clear answer as being a better one. You want each person to make their own choice and decide that way. So besides questions, you can also have samples that can be biased. So for example, every voluntary response sample will be biased because you can't be sure if the people who choose to respond are representative of the population. So voluntary response meaning that people will choose to respond whether or not they want to. Location where a survey is conducted can also cause a sample to be biased. So for our next example, we want to know how many of our classmates have cell phones, and to determine this, we send in every classmate an email asking, do you have a cell phone? So the way that this might affect our survey is you would think that a person with a cell phone probably has a higher chance of answering their emails. So students who answer emails are probably most likely to have that cell phone. It enables them to answer that question a little bit easier. So you want to make sure you collect your data in a way that's easiest, or it's easy for everyone to respond at the same level. And that last page of the notes, we're actually going to leave that out of the video. We're going to cover those a little bit separately, so we're not doing that last page. I'm instead going to do that a little bit differently, and we'll be practicing that a little bit more in class with our two-way frequency tables. So make sure you have it done up to here, and we'll see if we can answer any questions in class.